Hello everyone, my name is Sergio Lopez and I'm a software engineer working in the virtualization team at Red Hat. And in this presentation I'm going to show you a proof of concept of an integration of confidential workloads into OpenShift. Let's start with a brief disclaimer. This presentation shows functionality provided by upstream code that is not currently part of any Red Hat product and is not supported by Red Hat in any way. Okay, so what we have here is a small OpenShift deployment with just a couple of nodes. One of them, this one, running on a machine with an AMD Milan-based CPU, which means it's able to rely on AMD SCB to launch virtualization-based trusted execution environment using confidential computing technology. On the other hand, we have this example service written in Go, which is simply serves this static secret through HTTP with TLS after authenticating the user with these hardcode credentials. Okay. So let's now suppose I'm a developer, an OpenShift developer, and I want to deploy this service into OpenShift. So what I'm going to do is I'm going to click on Add, and I'm going to choose Import from Git. I'm going to copy the repository address, and I'm going to paste it here. Now OpenShift will check the repository, find that it's written in Go, and will correctly choose the Golang-based builder image. It will fill some defaults, which I'm going to leave them as they are. And I'm going to create a secure root for this application because we want the communication to be encrypted end-to-end. I'm going to choose to not allow any kind of insecure traffic, and I'm going to click on Create. Now, after clicking on Create, OpenShift will automatically create both the application and all the required services, and it will automatically start building it. Okay, it has cloned repository, is bundling with the Golang-based builder image, and has started has pushed the image into our internal registry, and it will start running the execution right away. In fact, it has already started, and I should be able to access it. That's the case. It's asking for the credentials, which are admin demo and password, and I get the secret served to HTTP with TLS. Now, the problem with this kind of environment is that I, as a developer, need to trust the administrator of the server where this workload is running on, because the administrator with root privileges is able to basically extract any kind of data or code from my workload. Let's see this with an example. Now let's imagine I'm the administrator of the server where this service that was deployed is running, and I'm going to try to extract its secrets. So I'm going to start by locating the container where the service is running. And now I'm going to inspect it to extract its process ID. There, I got it. And now I'm going to confirm that the process ID corresponds to the Go binary that was indeed generated from my sources by the OpenShift builder image. And I'm going to dump its memory. Okay, now I'm going to try to extract the secrets by looking for passphrase. And here is it, the secret passphrase. I can also look for admin demo, and I can also extract the credentials for this service. This is one part of the problem. The other part is that I can also locate the directory where this container is running. I can look here for the binary, and I can do wherever I want to do with it. This is the binary that is that has been built from my sources, and the administrator can copy it to another, extract it from the container, and copy it to another directory, extract it from the service, disassemble it, look it for strings, and also extract secrets from it, and analyze it in any imaginable way. Now, let's see how integrating support for confidential workloads into OpenShift will help mitigate this risk factor. So what I'm going to do now is I'm going to deploy the Saxon service, but this time has a confidential workload. So I'm going to follow the same process as before with the exact same sources, but this time I'm going to add -cw to the name. This is the way in which, in this proof of concept, we can signal the builder image that we want this service to be deployed as a confidential workload. And of course, this will eventually become a checkbox somewhere here, mapped to a build config field attribute. But otherwise, I'm going to leave it as before. I'm going to also create a secure route with pass-through, and I'm not going to allow any kind of insecure traffic. And click on create. It will basically do the same work as it did before with the non-confidential version of the service, and will automatically start building it. The first stages of the build process are the same as we have with a non-confidential version of the service, but then it will need to create. It will need to turn this into a confidential workload by creating an encrypted this image, by generating a secret and registering both the secret and the image into the attestation server. The attestation server is this service that is also deployed on OpenShift and must run on trusted nodes, and its role is to keep track of the confidential workloads available, alongside with the images and the expected measurements for these images. So when a confidential workload is started, the host will send a measurement of the contents of the confidential workload to this attestation server, and the attestation server will verify if the contents matches with the expected value, and if that's the case, it will reply with the secret that the host needs to actually start executing the confidential workload and access the actual workload that is running inside it. We should eventually see a new event here with the register of the image. Here is it. We receive a new image, which is with the name we created before, with the hash, and we have the kernel command line with its base 64 encode, and in our case contains not only the kernel parameters but also the secret to open the storage, which contains the workload, and the environment parameters of the workload itself. The secret is encrypted using relying on SCV technology in such a way that only the trust execution environment where the confidential workload is going to be running is going to be able to decrypt it. We also see that we have received a new request for attestation, and the attestation has verified successfully, which means that the confidential workload we have deployed should be already running. Okay, that's the case. I'm going to open this service, and same way as before, it's asking us for our credentials, password, and we get the same secret, this time through the confidential workload version of the service. So now let's try to do the same thing we did before, and let's try to extract the secret from it. Let's start by doing the same thing we did before, which was locating the container where this workload is running. Now let's inspect this container to find out the main process ID. And let's see what is running with this process ID. Okay, so this time, instead of finding the Go binary built from the developer sources, running has the main with the main process ID. What we see is the OCI runtime itself running with this process ID, and that's because this OCI runtime is linked against libkrun-tee to be able to launch virtualization-based trusted execution environments, which are a special kind of virtual machine. And everything related to the workload is actually running in this special kind of virtual machine, so we don't get to see any of its processes here from the host side. So, but of course, we can go ahead and dump the whole memory contents of this virtual machine. And we can try to find something useful in them. But since everything is running encrypted, even the memory itself, thanks to AMD SEB, we should not be able to find anything useful here. And that's the case. Now let's try to extract the binary or the main binary of the workload. We are going to once again inspect the container. To find out the path where the container is running, and we are going to get into this path and look for the binary. But this time is nowhere to be found, and that's because everything related to the workload is actually stored in this lax encrypted this image. And since the secret to decrypt this image is stored in the attestation server, which is running on a different machine on the trusted side of the OpenShift of this OpenShift deployment. Despite that I have administrator privileges on this server, I'm not able to decrypt any contents and nor to extract any useful data nor code from the running workload. And this brings us to the end of the presentation. Let me rerun the disclaimer again. This presentation shows functionality provided by upstream code that is not currently part of any Red Hat product and is not supported by Red Hat in any way. And with it, I hope you enjoyed this session. I hope to hear your feedback, and thank you for listening. Bye bye.